Okay, so we're in chapter 20, trying to finish off the class. Chapter 20 is about a new statistic that we can use to do confidence intervals and hypothesis testing about the population mean. Let's see how it goes. So it's here, it's called T. The chapter is about using T to make inferences about a population mean. A new statistic T, which is x bar minus mu over S divided by the square root of n, is now introduced to replace the old-fashioned Z, x bar minus mu divided by sigma over root n, and is used if sigma is not known. So we were talking about how do we accommodate the idea that we might not know standard deviation. And the answer is we can replace sigma in the formula with S. What that does is it gives you a slightly different shape distribution, but pretty much the same method of operation with critical values that you used for Z, and the same exact framework for how you reject the null hypothesis at a significance level. All those things remain the same. We still have assumptions that we need. The assumptions here now are simple random sampling and a normal population distribution. So we still need that sampling that represents the population, and we still need normality. Why do we need normality? Well, we need it if the sample size is small, because if the sample size is large, then x bar will be approximately normal. We know that by the central limit theorem. And S will be close to sigma, and we'll really pretty much have Z if the sample size is large. Okay, here are the formulas, corresponding formulas for a confidence interval. X bar plus or minus T star S over root n. So we compare that to x bar plus or minus Z star sigma over root n for Z. So all that's happened is that Z has been replaced by T and sigma has been replaced by S. And then the test statistic, we're going to use T, x bar minus mu naught. Mu naught is the null hypothesis mean, divided by S over root n. We compare that to the Z statistic, which we wrote was x bar minus mu naught sigma over root n. So it looks the same. The quantity in the denominator, this, is called the standard error of the mean. And you'll see that if you look at computer output, quite often it'll say SEM to stand for that quantity. If you happen to know the standard deviation of the population, then we can get the exact value for the standard deviation of the sample mean. It's sigma over root n, but when we don't know what the standard deviation is, we'll put the sample standard deviation there and divide by root n. That gives an estimate of the standard deviation of x bar. Either one of those things is called the standard error of the mean. It's the standard error of x bar, either the actual standard error, which is this number here, or the estimated standard error, which looks like that there. Either one we call SEM, depending on the situation. Ordinarily, we don't know sigma, so SEM ordinarily is S over root n. So that's our introduction to how the T statistic works, and then we'll look at more details in a minute.